Now that we've gotten really comfortable with solving for missing angles and for variables, we're going to start talking a little bit in between about proving lines are actually parallel. If you look at these pictures on the screen, they're missing something really important. And I'm going to put it there and then I'm going to erase it. Remember that we had these arrows on the parallel lines. I'm going to color them in here just for sake of, well, you notice these don't have those. These don't have those parallel line markings. And that is a really important thing to understand. If they have not somehow given you an indication in the picture that the lines are parallel, then we can't assume that they are, even if they look this way. Okay, we just can't assume it. Now that we're in upper level math, we have to actually take our time, look at what's given to us in the picture. So in each of these pictures, each of these pairs, we have one where the lines are parallel, and we have one where they aren't, but they might look like it. So what I'm going to write here is if corresponding angles are congruent. This is a rule, also called a theorem or a postulate, and I'm going to write those words. Those are vocabulary words. Theorems and postulates are just extra vocabulary words for the word rule. And these are a series of them that help us to prove that lines are parallel. So here we have corresponding angles, remember, in the same position. But the rule says that the corresponding lines corresponding angles, have to be congruent. And congruent is another word for equal. Let's remind ourselves what that means. So if you were looking at the picture on the left and the picture on the right, you might think that one of them looks good and one of them doesn't. And this is the one that we want, where the corresponding angles are congruent. Now, what if we talk about alternate interior angles? The rule there says that if alternate interior angles are congruent, then the lines are parallel. So here we have alternate interior. Which one has alternate interiors where they're the same amount? And this one does. Now the important thing before we move further down into your packet, and this is, by the way, page, I can't get my recording thing to move, I think 22. The important thing to remember that we need to have something in both neighborhoods. Notice how the corresponding angles have something in the top neighborhood and in the bottom neighborhood. Same thing with the alternate interior angles. They have something in the top neighborhood and in the bottom neighborhood. It's very important when we're proving lines are parallel. Now, if alternate exterior angles are congruent, starting to see a pattern here, right? Lots of congruent relationships. Then the lines are parallel. So let's look for the one. Here's our alternate exteriors. Which one, the left one or the right one, is the parallel one? I think you can see that the one on the left has the 24 and the 24. So that one is the parallel one. Make sure I got my pen. Now this one's different. If same side interior angles are supplementary, and remember supplementary means they add up to 180, and that's because of this. if we were to label our BB, LL, BB, LL, these two would not work because 76, see how they're a B and an L? They would have to add up to 180, and they don't. Whereas with this one, BB, LL, BB, LL, these B and L's add up to 180 because 104 plus 76 is 180. So this is the one. This is the one that you want. Now this also goes for same side exterior as well. They have to be supplementary. And here we go. If same side exteriors are supplementary, a little bit long for that line, then the lines are parallel. Now these are both same side exteriors, but which ones add up to 180? That add up to 180? No, that's too big. This one must be it. Let's just double check our math. 5 and 5 is 10. All right. So those lines are parallel. These are not. Now, if you get a random pair that fits into the big and little rules, and let's write those big and little rules down here in our notes, just to remind ourselves. We have 3 of them. We have the B's equal the B's, the L's equal the L's, and the B plus L has to add up to 180. So if they fit that B and L pattern, and we have top and bottom neighborhood, then the lines can be parallel. But we can't have something in the same neighborhood. See how there's something here in the top neighborhood, something here in the bottom neighborhood. So far I can consider those, but I got to go through, let me erase my circles. I got to go through and label my B's and L's and see which one works. One will and one won't. Okay, so here I have a B and an L. Well, that looks like it adds up to 180. Let's see if we can figure out why this one doesn't work. Oh, I see why. Because this one is a B and this one is an L. So when you add them up, they don't add up to 180. They add up to something much bigger. So that means that these lines are not, and these lines are parallel. So we'll be practicing that in our packet when we come back together.